This video is about the hyperbola and its parametric representation. A hyperbola fulfills the following equation: x squared divided by a squared minus y squared divided by b squared is equal to 1. So all points x, y fulfilling this equation lie on the hyperbola. You see here there are two parameters, a and b, and they are both greater than 0, and they are given. You see the analogy to the ellipse, but instead of the plus, here there is a minus, and the minus changes the curve dramatically, so really extremely. So before we sketch the hyperbola, we have to express this equation in terms of y. So we have to calculate y from this equation. For this, we subtract 1 and move this part, the negative part, to the right. And now we can express y. So we multiply by b squared, and we take the root at the same time. So the remaining term, the root of this, if you take the square root, if you extract the root, you have to consider plus or minus. Don't forget this. So, in order to sketch this, we wonder what happens if x goes to infinity. So what happens for very large x values? And in this case, the minus 1 here does not play a role. So neglect the minus 1 and compute the root of the remaining variables. So we get y is equal plus or minus b. Square root of x squared is just x, and square root of a is just a. So you can rewrite this as plus minus b over a times x. So these are the so-called asymptotes. So these are two lines going through the origin, and the curve approaches these lines for very large x values. So now we are able to sketch the hyperbola in the xy coordinate system. So we start sketching these two asymptotes, the lines, and for this we use a rectangle. So here is a minus b and b. Using this rectangle, we can draw these two asymptotes now. So this line is the line y is equal b divided by a times x. You see the line goes through the origin, there is no intercept, and the slope is b over a. The same is here, but with a negative slope. Goes through the origin, but the slope is minus b over a, so negative slope. So if we look at this hyperbolic equation here, we start first for positive x values. So I write this down here for positive x values. So in particular, you see the root is only well defined if x is greater than a, because or greater equal actually, because if x is smaller than a, this fraction here is smaller than 1, and the term under the root is negative, and you would get a complex root. So this fraction must be bigger than 1, and this is in the case if x is greater or equal a. So the root is not defined between 0 and a. So in this region here, inside the rectangle, there is no curve. So we start with the smallest x. So if x is equal a, what happens if you plug it into the equation here? If x is equal a, you get 1 minus 1 is 0, so the y is 0. So we can sketch the first point here. It's on the x-axis. So next we only consider the positive branch of the root, so only plus b. And you see, this is a root function, and the asymptote is b over a times x. So it must look like a root function, but the asymptote is here, approaching the line. So this is the right upper positive branch. So what else do we have? We also have a negative branch. So this means just you mirror this according to the x-axis. So it's again a root function, and it should approach this line here. Yeah, this should be a line. So the same holds for negative x values. So if you plug in negative x values here, they're gonna be positive because of the square. So this simply means the whole curve on the right side is mirrored on the y-axis. So you have the same on the right side. Starting at this point, here is the asymptote, and here we have this root behavior, and also down here. So sorry, it's not so easy to sketch with this graphics tablet. I want to point out that this is a curve and not a function, because for a function, each x value only has one y value. You see here for one x value, we have two y values. Actually, the curve is mirrored 4 times. So the right upper branch is mirrored on the y-axis, then on the x-axis, and again. So next, we want to find the parametric representation of this curve. So how to do that? We do it in a reverse way, so to say. I write it down. So a curve, a parametric representation has a parameter t and an x and a y coordinate, depending on this parameter. And I claim that it can be expressed as a times cosine hyperbolicus t and b times sine hyperbolicus t. So we need to verify this assertion. More precisely, we have to check if the parametric representation fulfills the hyperbolic equation from the beginning. And this is simply done by plugging the parametric representation into this hyperbolic equation. So I start. So we check if this is fine. So x squared, depending on parameter t, divided by a squared, and the same for y. So you plug in. And you see here that the a square cancels out the b square. And you know from the hyperbolic functions that cosine hyperbolicus squared minus sine hyperbolicus squared is equal to 1. And this is actually our hyperbolic equation. So we have proven that. What else can we do? We can look at the parameter range more closely. We have not talked about this. So first of all, where is the starting point? If the parameter is 0, so we plug into the parametric equation. And you know from hyperbolic function properties, cosine hyperbolicus is at 0 is 1, so a remains, and sine hyperbolic of 0 is 0, so remains 0. So this is our starting point, the initial point, and this is here, yeah, this tiny point. X is a, y is 0. What happens if we increase t? You know, if you look at the hyperbolic functions, the cosine hyperbolicus increases and also the sine hyperbolicus increases. So this means by this parametric representation, we only describe this right upper branch. So we pass through the right upper branch from this point a0 and we go upwards. So how to describe the other branches? In this case, you have, for example, for the right lower branch, the y values are negative, so you have to put a minus here. So maybe I use this color here. So if you want to describe this one, the a cosine hyperbolicus t is the same, but the y value, you need to put a minus in front. And the same idea on the left side. Here the x values are negative, so a minus in front of a for the left upper branch. And here is a plus, and for the last branch here, in the third quadrant, you need 2 minus.